there, in this video we are learning how to find out the probability using the tree diagrams. Here mainly we are focusing on those questions which are without replacement. So it says that the bag contains 3 red and 7 blue balls. A bag is picked and not replaced. So here the keyword is the not replaced, which means that let's say initially in a bag, if you're having 10 balls in total, if you pick up one from it, then the remaining number of the balls will not remain as 10, but it would be turned to 1 less, which would be 9. Okay, now I'm going to draw a bag here. So this is a bag and there are the 3 red and 7 blue balls. So 1, 2 and 3 are the red balls. The remaining are the 7 blue balls. So it would be 1, 2, 3, 4, 5, 6, 7. So this is the total number of the balls in the bag would be 10. Okay, now this says that complete the tree diagram. So before we complete the tree diagram, first we need to keep this in our mind that the question we are doing is a not replacement question. So I'm going to start with the first one. The 2 different colors in the bag is a red and a blue. I'm going to label R, B using the initials of the colors, so which would be here. The probability of having a red ball would be 3/10 and the probability of having a blue ball is 7/10. So the total number of the balls initially in the bag were 10, but because they picked up one ball from the bag. So we don't know what ball they are picking up from the bag. So it could be the red ball or it could be the blue ball. We need to consider both the situations if they are picking up the red ball or the blue ball. All I know that is at the moment it's not replacing back. It means now the new total number of the balls would remain in the bag. Instead of 10 now it would be 9. So I'm writing down all the denominators with a 9. Maybe if the ball they picked up is a red color ball. So I imagine that the first case is I'm taking this, the ball is a red color ball. So what's the probability now of having a red ball would be 2 out of 9 balls, where the probability of having the blue ball would be the same, which is 7/9. Remember that we know that the sum of the branches should be every time add up to 1. So if you do 3/10 time plus 7/10 would be add up to 1. So 2, 9 plus 7, 9. So 2 plus 7 is a 9. So 9/9 would make 1 as well. So them two are adding up to 1 as well. So now we're going to go on to the next now. In the first one, we consider that the ball that we picked up is the red ball. Now we are considering that the ball we are picking up is not the red ball, but it's a blue ball. So now we are having 1 less blue ball. Well, to write down the probability of the red balls is now 3/9. To write down the probability of the blue ball would be 6/9 now, because 1, 2, 3, 4, 5, 6. Here we have completed the tree diagram. And now we're going to read what actually they're asking. So find the probability of the same color. We are finding out the probability of getting the same color of the balls. So it could be red and red, the first combination, or it could be blue and blue, which is the second combination. To get the probability of the red and the red ball would be 3/10 times by 2/9. The probability of getting blue and blue would be 7/10 times. The next blue is 6/9. We're going to simplify the fractions together. So it would be 6/90 plus 7 times 6 is 42. So it would be 42/90. Because we have got the same denominators, we add the numerators. So 6 plus 42 and then 90 in the denominator. So when you do 6 plus 42, it would be 68/90. You see that because 68 and 90, they both goes in a 2 times table. You're going to simplify it by dividing the top and the bottom by 2, and you'll get the probability of the same color would be 34/45, because the half of 68 is 34 and the half of 90 is 45. So this is very important for you. First of all, read the question carefully to recognize that whether the question is about with replacement or without replacement. And if it's without replacement, then the denominator would be reduced by 1. I'm going to start by reading the question. Here this says that there's a bag of sweets which contains 2 of the toffees and 5 of them are the chocolates. So Lewis eats 2 sweets. Now they are not using the word without replacement, but they are saying that Lewis eats 2 sweets. It means it's again leading to without replacement. Because if we're having a sweet and we're going to eat the sweets, of course we can't put it back again in there. So it would be reduced by 1 in that situation. So not always they give you like really in a clear words that it's a without replacement question. But sometimes it makes sense as well that 2 sweets, if you're eating one of the sweet, then it would be 1 reduced in the total. We're going to fill in the tree diagram now. So initially we have got the total number of the sweets would be 2 plus 5, and that would be 7. So the two sweets, type of the sweets we are having is a toffee and a chocolate. So there's a toffee, there's a chocolate, there's a toffee, and there's a chocolate. I'm going to write down the first fraction, the first one with the denominator of 7. So there's a 7 here and there's a 7 here. Now, two of them are the toffee, so it would be 2 on the top, and here it would be having 5 on the top. We know that 2 plus 5 makes 7, so that would be adding up to 1 then. Let's have a look to the next one now. Because this is a question of without replacement, so when I write down my next time fractions, they all be reduced by 1. So before we had a 7, the total. Now we see that the new one would be 6. So I'm writing down the denominators to be 6, 6, 6. It's sometimes really good, easy for at the time of learning, that visualizing really helps. So what I'm going to do is I'm drawing it now, the two toffees. So I've got 2 toffees. I'm labeled them with the T and T. And then in a bag, the other thing I've got is 5 of them are the chocolates. So 1, 2, 3, 4, and 5. And I'll C. So I've written down C's for the chocolates and T for the toffees. Now, because we have eaten, or there's a one sweet less now, it could be the eaten one could be a toffee or a chocolate. In the first one, I consider that the first one which is eaten is a toffee. So now what is the new probability of having a toffee would be 1 over 6, because we have got one remaining toffee only. And what is the new probability of the chocolates would remain same, which would be 5 over 6. Remember that 1 6 plus 5 6 would give you a sum of 1. So it means that we need to make sure the sum of the two branches should be add up to 1. Now we're going to consider now this time that the eaten one is a chocolate. So I'm going to put the cross on one of the chocolates. So what is the probability of having the toffees would be now 1 and 2. So the total number of the toffees is a 2. The probability would be 2/6. Now the new probability of having the chocolates would be 4 over 6, and them 2 would be also adding up to 1. So 2/6 plus 4/6 would be giving you 1. We have got the tree diagram to be filled in now. What we're going to see in the part I, find out the probability that both of them are the toffee. So the toffee and the toffee. So having the toffee for the first one is 2 over 7. Getting the toffee in the next one would be 1/6. You multiply the numerator with the numerator and the denominator with the denominator. So the probability of getting the 2 toffees would be, because they both are the even numbers, they both goes in a 2 times table, and it would be 1 over 21. Now we have got the next example, next part now, which is, now we have got the next one now, which says that one of each sweet is picked. It means that we are looking for the combination of toffee with the chocolate, and we are looking for the combination of a chocolate with the toffee, because it says that one of each is picked. So the combination of a toffee with the chocolate is, here we have got a toffee and a chocolate. We're going to multiply the fractions together, which is 2/7 times 5 over 6. And getting a chocolate with a toffee would be 5 over 7 times 2 over 6. We're going to simplify the fractions now, which is 5 times 2 is a 10, and 7 times 6 is 42. The other one would be 10 and 42 again. 42 is the common denominator. 10 plus 10 is a 20. We can simplify them by making the half of them, which would be 10 over 21. So the probability of getting one of each sweet to be picked is 10 over 21. Here we have got a next example, which is slight complex. Why I say it's a slight complex, because we have got now 3 of the different things given. So it says that a bag contains 5 blue, 3 red, and 2 green counters. I take out one counter without replacement. Here it's like they are telling you it's a without replacement question. Then another, what is the probability that they will be the same color? Again, we'll be starting by filling the probabilities. So the 3 different colors are red, blue, and green. Are labeled red, blue, and green. Again, red, blue, green. Then again, red, blue, green, and red, blue, green. Okay. Now, this is the first one shows the first time to be picking up. The next one shows the next time to be picking up. So now the total number of the counters which we are having is 5 plus 3 plus 2, which is 10. So in the first case, the denominator of each of them would be a 10, 10, and 10. Because we have got 5 of them are the blue counters, So I'm going to write down 5 with the blue. 3 of them are the red. So this is 3 here. And 2 of them are the green. So that would be here. Now I'm going to write it down now in a bag. Now I'm going to draw the bag again. So this is my bag. And the red counters are 3. So I'm going to draw the 3 red counters, which is red in color. Then 5 of them are blue. 1, 2, 3, 4, and 5. And then the other one is a green counter. So I'm going to use a green color to draw the green counters. And there are 2 of them. Now, because we have picked up and without replacement, so the denominator is now going to reduce by 1. So each time now denominator for each of them would be a 9, 9, and 9. Then for this one would be 9, 9, and 9 here. And the other one would be 9, 9, and 9 here. So I've written down the denominators first. Now, maybe I consider that the first time which I'm getting, it could be a red counter. So I'm going to put a cross on the red and I'll be writing down the probabilities now. Because I've chosen the red counter, now what would be the new probability of having the red counters would be 2 over 9, where I see that the blue counters remain the same, which would be 5. And I see the green counters remain the same as well, which would be 2. Now, you see that 2 plus 5 makes 7, 7 plus 2 makes is a 9, so 9 over 9 gives you 1. So the sum of these 3 are adding up to 1. To fill in the next one now, I assume that now the counter that we picked up is not the red counter this time, but it's going to be the blue counter now. Yes, I'm going to put a cross on the blue counter. So what is the probability of getting the red counter? So the number of the red counters is 3. The number of the blue counters are now 1 reduced, so it would be 4. And the number of the green counters remain the same, which would be 2. Now, for the third time, I consider that the counter that we have picked up is not the blue counter, but this time is going to be the green counter. So I put the cross on the green color and see that now the red counter stays the same, which is 3. The blue counter stays the same, which is 5. And now the green counter is 1 reduced with what we are having, so it would be 1. So once you filled in this thing now, this says that find out the probability of getting the same color. So it would be red, red, or blue, blue, or green and green. To having the red and red, so we'll be having 3 over 10 times 2 over 9. Having blue and blue would be 5 over 10 times 4 over 9. And having green and green would be 2 over 10 times 1 over 9. You simplify them, so it would be 6 over 90. The other one would be 5 times 4 is a 20, so 20 over 90. And the last one would be 2 over 90. Because you've got the common denominator 90, you add the numbers written on the top. So 20 plus 6 is a 26. 26 plus 2 is 28. We clearly see that both the numbers are divisible by 2. So half of 28 is a 14 and half of 90 is a 45. You can't simplify them together. So probability of having the same colors is going to be 14 over 45. So now I'm going to go on to the last example of it. There are the n number of the sweets in the bag. So I'm going to write it down, the total number of the sweets. We don't know in terms of the number, but it's n. So I'm going to write down n is the total number of the sweets here. The next is 6 of the sweets are orange. So I'm going to use now the orange color here. So one is the orange color, the next is the yellow color. So we have got orange, we have got yellow, we have got orange, and we have got yellow. Because it says that 6 of them, the sweets are the orange, so I'm writing it down. We have got the orange is 6. The rest of them is the yellow, so I'm going to write down the total is n number of the sweets. Out of them, 6 of them are the orange, so the remaining would be n minus 6. To write down the probabilities now, you're going to have the number of the orange sweets would be 6 over n. The number of the yellow sweets would be n minus 6 over n, because the denominator is always the total number of the sweets. Now to have the next part now, because in the box, if I say that we have got 6 of them are the orange sweets, so I'm going to draw that. 6, 1, 2, 3, 4, 5, 6. 6 of them are the orange. The remaining of them is the yellow. So we don't know how many are the remaining, like because we know the total is n. So we could have number of the sweets here. We don't know how many are these yellow ones. It could be even more. I don't know how many are there in total. But we know how many are the orange sweets. This says that find out the probability of the 2 orange sweets. So the probability of the 2 orange sweets. Now, if I assume that the first one chosen is to be the orange, so it would be 1 reduced then. Before, the total was 6. Now it's going to be 5. And we do 1 less than that. So it would be n minus 1. Because it's a question of the without replacement, because she eats, so of course the total would reduce. So n minus 1, n minus 1, n minus 1. The probability that the Hannah eats 2 orange sweets. So probability of orange and orange. We don't need to fill in the remaining information. It's not needed. So I'm going to choose this combination where we have got 2 orange of them. We're going to multiply them together. So 6 over n times 5 over n minus 1. And this says that the probability of getting 2 orange sweet it's equals to 1/3. So I'm going to make the whole thing equals to 1/3. This says that when you do the simplification, you should come out with this. We're going to see that when we simplify what we are getting out there. So I'm going to simplify the two fractions. 6 times 5 is the 30. In the denominator, we're going to write them down n times n minus 1 then. And the whole thing would be equals to 1/3. We do the solving part where we'll be able to get this equation then. So you multiply 3 on the other side and this time is going to multiply by 1. So 3 times 30 you're going to do here. Where on the other side, if you multiply anything by 1, would remains the same, which would be n times n minus 1. You do the simplification of the left hand side. 3 times 30 would be 90. And you expand the bracket on the right hand side. So it would be n square minus n. Because we are trying to write it down in the form of n square minus n minus 90. So you do the next step by taking everything to one side, because you should have one of the other side needs to be equals to 0. So you take this 90 on the other side, you'll be having 0 equals n square minus n. The inverse of plus 90 is a minus 90. Or you can rewrite this in the form of n square minus n minus 90 equals to 0. And this is what we are looking for. So we have got the show that thing. So what happens with these sort of questions is basically when the students see, generally it's not given in terms of the number, but there is some variable given, they get confused about it. But I suggest that it's just like we are following the same thing. There's nothing different we have done in this question as compared to the other ones. So always read the questions, break the question into different parts, try to attempt it, use the information, take some time to think what the question is about and how you can get to there. So think of the methods, think of break down the question. These little things really helps in solving the harder questions. So this is the whole explanation on the topic. So your comments are always appreciated, your feedback is always appreciated, and in the even comment box you can write down what is the next video you want me to make on any topic. So I'll definitely going to work on it then. Thank you very much for watching the video.